Hey guys, so in this video we will be going over the difference between height and depth in a binary tree. So height and depth are important concepts to understand because a lot of interview questions deal with these two concepts when asking about certain elements concerned with binary search trees or binary trees. For example, it might ask for the height of a binary tree or the depth of the binary tree, or ask certain harder questions such as what's the height of the largest subtree, or what's the largest depth that a binary tree has. So understanding these two concepts is pretty important in the world of binary trees. So one way to think of height is to imagine it as it is in the real world, where say you have a person and you're trying to measure their height from the ground up. In this case, we have to measure with 0 on the ground and move our way up until we reach the tippity top of their head. And that's how height is measured, is with 0 being on the ground and 5 being on the top. Similarly, in a binary tree, where we have 8 as the root node, and we have the binary tree like so, we have to measure height by measuring from the leaf node all the way up to the root node. Now, more specifically, we have to be able to find this mathematically, and the formula for finding height is max of left node and right node plus 1 will give you the height of a specific node. So for example, the max of the left node and right node of 19 is going to be -1 and -1, since this node is a leaf node, and because of that there's no nodes that this node has children of. So since this node is a leaf node, we can say that -1 and -1 are the left node and right node respectively, and the max of -1 and -1 is -1 plus 1 is 0. So we just found the height of the leaf node, which is 0. And we do this for each and every node until we get to the top. So for 2, we get that the left node is has a height of 0, and then the right node is missing. So the right node has a height of -1. Max of 0 and -1 is 0, plus 1 is 1. So 2 has a height of 1. And let me make it a different color. So 2 has a height of 1, and 19 has a height of 0. Now, what about 6? 6 is a leaf node just like 19 is. So although it might seem like 6 would have a height of 1 since it's in the same area as 2, we have to look at it as it's a leaf node, so thus the height of its children are -1 and -1. So similarly to 19, we have 6 to have a height of 0. Now 3 is the same way. Max of left node, which is 6, and right node, which is 2. They both have height of 0 and 1. So max of 0 and 1 is 1, plus 1 is 2. So 3 has a height of 2. 4 is another leaf node because it has no children. So thus, it's going to have a height of 0. And finally, 8, the max of its 2 subchildren, which are 3 and 4, which have heights of 2 and 0 respectively. The max of 2 and 0 is 2, plus 1 is 3. So the root node has a height of 3. So with this method, with this mathematical formula, we've been able to find the height of each and every node in this binary tree. Now that we discussed height, we want to also know what depth is, and depth is the complete opposite of what height does. So depth measures from the top or the root down to the leaf, whereas height is measuring from the deepest leaf to the top. So one way to think about this and remember this is to think about sea level, and you're measuring your way down to the height of, say, a submarine within the ocean floor. So how you would measure the height of the submarine is you start at the sea level, which is 0, and work your way down until you reach the height of the submarine. So this is what depth is. And in a binary tree, and let's use the same example as we did for height, we have it so that 8, which is the root node, is going to have a height of 0, just like how we had a leaf node in the height represents 0. And then 3 and 4 are the next nodes in the sequence. In other words, they're the children of 8. So since they're children, we add 1. So they both have a depth of 1. 2 has a depth of 2 because it's a child of 3, which has a depth of 1. Similarly, 6 has a depth of 2 since it's a left subtree, just like how 2 is the right subtree. And then finally, 19 is the left subtree of 2, which has a depth of 2. So 19 has a depth of 2 plus 1, which is 3. So depth is a little bit easier to understand because you simply have to start at the root, which is always going to be 0, and you work your way down the binary tree, adding 1 every time you reach a child of a node that you previously defined. So that is how you find the height and depth of a binary tree. And I'm going to link the next video in this series, which actually deals with height. And we're going to do an interview question related to height. So hope to see you guys there. And let me know if you have any questions. Peace.